So in this lesson, we're going to look at some practical applications of trigonometry. So you've done Pythagorean theorem, and we kind of tested that separately, but don't throw that away. That's going to come back up again. And we've looked at sine, cosine, and tangent, and the three ratios, the three trig ratios for right angles that use sine, cosine, and tangent. So now we're going to apply the math in the trade. So where do we use trig ratios in the trade? Well, one place is find the angle to attach a stair rail. So the angles here where the stair rail joins and the angles that the balusters are cut at require us to find an angle. So that's one place we can use trig. We're actually going to use that in the next lesson that you're going to have for next week. We can use it to determine depth or width in excavation. So a little bit towards surveying for site layouts. So that's another place it gets used. That's the example I'm given the most often when I ask carpenters, where do they use trig? At least the carpenters that are on our campus. Finding the grade of a slope, that's very easy. You can very easily figure out whether you've got a correct grade. So you want, usually if you're building a house, you want to have the soil slope downwards away from the house so that water runs away from the house as opposed to running towards your foundation. So when we're finding grade, we're going to use trig, and we'll look at some examples of that in this lesson. Building rafters, you need to know all the angles that you have connections at. We're going to spend some time on that in the next lesson because you're going to do that in your assessment for this section. So the building rafters question will come into play there. And then darn old gazebos use lots of trig. I haven't decided whether I'll give you any examples of that or not, but that is one place where you would see it. I may give you an example just for the sake of having shown it to you so you could figure out the area of the gazebo. All right, so those are some of the places you would use it. You can probably think of some more places where you would use it. If you were trying to build a roof around a bay window, putting a seat in a bay window, anywhere where you're figuring out angles. If you need to know what angle to set your saw at, and you know a length and a width or a rise and a run, you could use trig to figure out what the angles are. So that's where that will go for now. So there's two terms I'm going to use in today's lesson. So today's lesson is going to deal mostly with using trig to find slope or depths in excavation type scenarios. So there's a couple terms. One of the terms I'm going to use is angle of elevation. So angle of elevation takes us from level. So we follow the sight line across level, or it may be a string we have across level. And then we follow the sight line up towards an object. The angle of elevation is the angle through which you would look. So it's the angle upwards, elevated from level. Angle of depression is the angle downward from level. Okay, so how much does it depress from level? So those two angles we're going to use quite a little bit. So left an L off level. So we can think of the angle upwards from horizontal, and then you've got the angle downwards from horizontal. And those are going to be key to keep in mind. So one of the things we're going to do for a lot of these applied questions is first we're going to find out where is level, and then we're going to be looking for an angle downwards or an angle upwards, and we'll have to think about which angle is actually useful to us. All right, so this is not something you're probably going to do unless you're cutting trees down on a property. I had an elderly gentleman cut down some trees for us in one of our properties. And I noticed he would go around and he would size the tree up with his thumb. He knew he'd stand X number of paces back, hold his thumb up, and he knew by how far he could see the shadow of that tree on his thumb when he was holding his hand out. He knew exactly how tall that tree was, where the tip of the tree would end. He was using trig without actually calculating anything. He was using equivalent angles. So basically what he would do is he would kind of figure out how many paces this way, and he would figure out, okay, what's that height there? Okay, I know that this height corresponds to X number of feet if I'm so many feet out. It's kind of a weird way to figure it out, but it actually uses trig. This particular individual, I would be surprised if he actually knows his SOHCAHTOA, but he applied that math. It's been something he was taught long ago when he worked as a lumberjack. It was how to size up a tree using what we call a similar triangle, and it relates to our trig. Now what we're going to do is we're actually going to use some angles. So you could try making this at home if, well, most of you guys I think are too young to have kids, but there's a few of you that might. This is something really cool that you could actually make. This is what's called a clinometer. So it's a tool that allows us to measure the angle of elevation from a site. So what you do is you take a straw and you attach it to a protractor. If we were able to, if we had class in person, this is something that would probably take some time to make, but it's not one of those things that is easily done virtually in order to actually make it an activity that people follow through with. So we'll explain how it works and we'll just do some calculations with it. So you put a straw on a protractor, tape them, glue them, whatever. If you want to try it, give it a try. At the very center of the protractor, now notice it's at the center where the 90 degrees and the 0 degrees connect. We attach a string and then you attach a weight. And what you do, let's see if I can make this work. So we're going to pretend this pen is my straw. Okay. So what you want to do is you want to look through the straw and you tip it upwards until at the end of the straw, you see the tip of the object. So in this case, this individual is looking through and they just see the top of the tree. At that point, you measure what is this angle downwards from your string. Okay, the angle down from your string, if you take a measure, so here, well, we could do two different measurements. From 0 over here, it measures, if we look, it measures 135 degrees, okay? So that's our angle going this way. Then we can use that in order to figure out what is this angle. So what you do is we need a horizontal line. Okay, so if you have a perfect, so you'll notice this line is a string hanging down with a weight. It's going to hang 100% vertical. Okay, horizontal. I don't think I drew this horizontal, but I tried. Here's your horizontal line. And what's the angle in between the two? You have 90 degrees. This angle is our angle of elevation. Okay, that's our angle of elevation. So how do we figure it out? Well, we say, okay, I hit 135 here, minus 90 degrees to get to horizontal, because we don't need to include this angle. We just want the little angle in here. Leaves us with 135 minus 90. What do you get? 45 degrees. Okay. Now you'll notice if we had a mesh, and up here, I guess I did a pretty good job of drawing horizontal. We're at 45 degrees as well. If you notice, this protractor is measured 0 here and then measures back, and you could actually have measured 45 degrees on the inside. The two of them happen to line up. Now the reasons for that we'll leave for another day. Okay, so that's one of those little things. If you want to try doing one, you could. One of the uses you can use, if you, let's say you, your average foot length is, I'm going to say 11 inches. Okay. If you step in a line, heel to toe, and take 10 paces away from a house, 10 steps, 11 inches long would be 111 inches. Then you take your clinometer and you angle it upwards just until you see the tip of the roof. You can figure out exactly how tall that building is. You're going to be should be quite accurate in order to figure out. Now, I know for some of you, you use iPhones and they have a measurement tool in them that uses the camera. The measurement tool that uses the camera uses a principle like this. So it's able to predict how far away an object is, and it's able to use the angle at which you're moving. It has, we call it an accelerometer that's in your phone that helps you track distance and speed and stuff like that with GPS. And we'll leave that geeky physics stuff out, but it's actually based on this trig principle. Some programmer has developed a program that allows you to calculate all of that stuff. It's actually quite cool. All right, so there's my little nerd out moment for you guys. I'm sorry. Now we're going to actually do some math questions. So this is the same question we just had before. So we have some of the numbers already. So using a clinometer, a person identifies a 45-degree angle of elevation to the top of a tree. If the individual holds the clinometer 5 feet 6 inches above the ground and stands 18 feet from the tree, how tall is the tree? I don't know a carpenter is going to figure out how tall the tree is, but the principles are all the same for us. We're going to use exactly the same math in another question. I just had a good graphic for this one. So angle of elevation is the first thing you want to label in our diagram. And if a diagram's not given to you, always draw a diagram out. Okay, it's going to help you a lot. I'll try to give diagrams for at least the first little bit. So sketch a diagram. So we know we have 45 degrees here. Okay, the individual is standing this distance. They're standing 18 feet from the base of the tree. And the height to their eye is 5 feet 6 inches. We want to know what is X. It's a little bit hard to see there. What is the height of the tree? This total height of the tree. Okay, so we need to find, I'll put the X out here. We need to find X, the total height of the tree. So how do we do that? Well, if you look at your equation or your triangle here, we can label this triangle quite easily. I'm going to label it on the white side. So the first thing we're going to do is we have our angle. Let's label the pieces that we know. We don't really care about this diagonal length. That's just the line that we're looking. It doesn't even, we don't need to know it in order to find the height of the tree, but we do need to know this height here. Because if I know this height, I can add it on to the height of my eye level. So this side is the opposite side of the triangle. It is opposite to 45 degrees. Down here, the 18 feet is my adjacent side. Now, SOHCAHTOA, we'll list everything up here. Okay, which ratio am I going to choose? Well, let's look at our ratios. Sine uses opposite and hypotenuse. I don't need the hypotenuse. I don't care about the hypotenuse. Cosine uses adjacent and hypotenuse. Again, I don't need the hypotenuse. I don't care about it. So both of these ones are out. We're not going to use them. Tan uses opposite. I want to know that. And it uses adjacent. I have that. So we're going to choose the tan ratio. So let's plug our numbers in. So the tan of an angle, our angle is equal to opposite over adjacent. The O comes first, so it's on. So the tan of 45 degrees is equal to the opposite side, that's going to be connected to the height of our tree, divided by the adjacent side of 18 feet. Rearrange it. Multiply by 18, multiply by 18. 18 times the tan of 45 gives us, putting those numbers into your calculator, you should get 18 feet. Little tip for you. Anytime you have a 45-degree angle, the adjacent side and the opposite side will always be equal lengths. Okay, so there's a little tip for you if you want to throw that in your memory bank. 45-degree angle will always give you an opposite and adjacent that are identical in length. So we know, okay, the triangle opposite side is 18 feet, so the tree height. Well, from my clinometer, I have 18 feet of height plus the height that I was standing or how high I was holding it, which is 5 feet 6 inches, gives us a total of 23 feet 6 inches for the height. So it's really not difficult to calculate. So we have, in order to find X, X is the opposite plus the person height. That's how we calculated that. All right, hopefully that makes sense to you. If it doesn't, please let me know. Check in with me. Let me know before you get to your final assessment. Let's look at example 2. So a person's using a clinometer again. This time, instead of looking upwards, they're looking downward, okay? They're looking downwards. First of all, a clinometer lets us measure from horizontal. So we're going to find our horizontal line. Okay. They identify a 31-degree angle of depression. So there's my angle of depression going down, 31 degrees. This gives me this big triangle here. So I go across and then downwards. Angle of depression is 31 degrees. Let me restart reading the question again because I can't pick up halfway through, sorry. Using a clinometer, a person identifies a 31-degree angle of depression from one edge of an excavation that has a width of 28 feet. So we have 28 feet across. We know that that's the width. How deep is the excavation? So I want to know what's the depth. If the clinometer was 5 feet 2 inches above the ground when the measurement was made. So here's our person, and this is 5 feet 2 inches. So if you look here, if I want to know the depth, it's going to be 5 feet 2 inches plus d is the height of my triangle that I'm going to get. So we're kind of doing a little extra calculation with these ones. Let's figure out how deep it is. First of all, which ratios are we going to use? I need to find this side of the triangle, which is opposite of 31 degrees. I know the adjacent side is 28 degrees. Which ratio uses opposite and adjacent? If you don't have it memorized yet, write them down. SOH, We don't need this one. We don't need this one. Tan has opposite and adjacent. So we're going to use tangent. So the tan of the angle is equal to opposite over adjacent. I keep writing it down, hoping it'll help you memorize them. So the tan of 31 is equal to the opposite side over my adjacent side of 28. So the opposite side is equal to 28 times the tan of 31 degrees, which is equal to 16.8 feet. Okay, and then I'm going to do a conversion. 0.8 feet times 12 rounds to 10 inches. So this is also equal to 16 feet, 8 inches. Why did I convert that? Now, Sam, I can't ask you a question to do a feet and inches conversion like this. It just doesn't work well in Sam. But the reason I converted to feet and inches is because I'm told this person was holding the instrument 5 feet 2 inches above the ground. So I know that this whole height is 16 feet 8 inches. I need to subtract the person height to get the depth. So the depth is going to be 16 feet 8 inches minus 5 feet 2 inches leaves us with 16 minus 5 leaves me with 11 feet, and 8 minus 2 gives me 6 inches. Okay. So it's 11 feet 6 inches deep. The tricky part of those ones is the triangle that you calculated also, it either included the height of a person or it didn't include a height of a person. So you had to add or subtract that in order to find the part of the triangle you actually really, in order to find the final answer that uses the triangle that you calculated. So these ones are a little bit tricky, but they're good questions to be able to figure out. Example 3, I like this one. I always have wished I had a house with a walkout basement. Mind you, sometimes there are more issues for flooding, depending on your height. So my brother's property is actually like this. This actually looks very, very close to his blueprint, the side view. So you have an entry on a main level, and then you've got your walkout basement here, and we have to be able to drop at least a story in height. So this question tells us the angle of elevation from point A to point B is 22 inches. You will see this question show up in your quiz, so pay attention to this one. The angle of elevation from A to B is 20 degrees, and the house is 32 feet wide. What is the difference in height between A and B? Secondly, what is the length of the slope? So 2 pieces to calculate. So the first thing we're going to do is draw a triangle. So angle of elevation means we're going from horizontal. So here's your triangle. We know that this is 22 degrees. The width of the house, so this length here, is 32 feet. What is that height? You'll notice there's one ratio we use over and over and over again. So label your sides. Here, this one is our adjacent. And this one's going to be the opposite. And this is our hypotenuse. So for A, I'm going to calculate A here so I have enough room to calculate B later. So A is what's the difference in height. So I'm looking for X first. So which ratio would I use? Now, opposite and adjacent, you should remember at this point uses tan. So the tan of an angle is equal to opposite over adjacent. So the tan of 22 is equal to, the opposite side is X over the adjacent side, which is 32. X equals 32 times the tan of 22. Multiplying those together, X is equal to 12.9 feet, or some of you like to do feet and inches, 12 feet 11 inches. Okay, there's the conversion if you happen to want it, but this is our final answer. So that's the change in elevation. Okay, now for B, we'll calculate B over here. B says, what's this length? What's the slope length? So if I want to find the slope length, there's 2 ways we can do it. First of all, I know the height now. So because I know that this side is 12.9 feet, I could use Pythagorean theorem. That would be perfectly viable. But what if you made a mistake calculating your height? I like to usually use a ratio that you know. So know both sides. So I know 32 is a number that's given in the question. There's no mistake in that. And 22 degrees, there's no mistake in that because that was given in the question. So I'm going to actually get you to think about what ratio would you use if we were going to use an angle instead of Pythagorean theorem. On an assessment, you can make a choice which one you use. But in this case, I want to actually figure out what is the angle. So using 22 degrees and using 32 feet, how can you calculate the height, or the slope length, which is the hypotenuse, many h's. So if we look here, we have the adjacent side and an angle. So sine uses opposite, cosine uses adjacent. So for B, let's use the cosine. So the cosine of an angle is equal to the adjacent over the hypotenuse. So let's plug in. Cosine of 22 degrees is equal to 32 over hypotenuse length. Okay. This is one of those ones that as people forget how to rearrange. So in order to rearrange this one, we actually do this little flip places. Remember, if you're looking for what's on the bottom in the trig ratio, you can trade places on the 2 sides. So H is going to be equal to 32 over cosine of 22. There's a long way to rearrange that. I went through how to rearrange that in the very first lesson in this section. Okay, so go back to lesson 1 for this week if you're not sure how to rearrange it. Now that we have that, we can just put this into our calculator. And you will find that H, the hypotenuse, is equal to 34.5 feet or 34 feet 6 inches. So that's your slope length. So not complicated. This one we didn't have to worry about adding on a person height or subtracting a person height because we just knew what the angle was. It didn't tell us that they were holding it above the ground. This question you will see one or two of them. You'll see two of them, I guess, just like this from this question to do on your quiz. Okay, so you will see this question again. That will let you reinforce that. Another example, how many degrees of slope are represented in the diagram? So this is a really easy way to check for the slope of a piece of land. You put a stake in on one side, you attach the string at the bottom, and then a stake on the other side, attach a string, and then figure out, well, what's the distance from horizontal? You know how far apart they are, or the string length, what's the distance from horizontal? Now, a couple years ago, we installed some drainage in our basement, and in order to have water flow go the direction we needed to in the pipes under the floor, we had to figure out, it was I think it was a quarter inch per foot of drop. So I actually used the string method in order to make sure we had the right amount of drop in the pipe so that it would drain to a sump pump the way it was supposed to, because we didn't want to have water collecting under the floor. It needed to have an easy exit point. So this is a very easy method in order to figure out heights. You just want to make sure you're measuring from zero. You could also, and we'll look at an example where instead of putting the string right at the ground level, we could put the string up a few inches. And if you put the string up a few inches and go directly across, you can do the same kind of calculation. You would just end up having to do like that person subtraction that we were doing before. So I'll try to put an example of that in a little bit later. Maybe next week I'll slip one in for you. So we want to find how many degrees of slope. So the degrees of slope is going to be our angle in here. Okay, so your degree of slope is always from horizontal down to the slope. It would never be from the slope up to vertical. That's just not logical. Okay, so in order to find that out, let's list our pieces. So we have adjacent side and I have opposite side. Well, remember from before, opposite and adjacent uses tan. So the tan of an angle is equal to opposite over adjacent, TOA. Opposite comes first. So the tan of an angle, we don't know what this angle is equal to, opposite is 9 inches over 100 inches, which is equal to 0.09. So now we need to find the angle. To find the angle, we're going to use that shift tan. So the tan minus 1, inverse tan of 0.09. And you will find you get a 5-degree slope. Okay. We could also go the other way. I could tell you you need a 10-degree slope. How much will it have to drop over 100 inches? And you would do the same kind of calculation, same kind of image would go with it. Just as a tip, you will see this question show up on your quiz as well. It's a nice, easy question to make sure you understand what it is that you're calculating. But this is a really, really easy one for you to actually do a set on to check. All right. And that's it. Oops, I thought I had one more question in here. Apparently, I've missed a question. I'm going to see if I can add that extra question in. Just give me a second. I'm going to pause here. We'll add the question in, and I'm going to give you one final example. Okay, so I found the missing example. I'm going to have to do a couple little modifications to it. I don't know what happened. Somewhere along the line, I must not have hit save. So we'll try to update that for you. So in this question, I want to determine the measure of each of the angles in this bay window seat plan. So this is the framing for a bay window. This would be similar framing to what I'd have in my own home for a bay window. It's easier to look at the flat floor plan than it is to figure out the angles on the roof. And I think you can probably predict why, based on the roof assignment where you had to think about, well, what if a roof is on an angle and you got to kind of visualize 3 dimensions. So this is just looking at the floor that's underneath of a bay window. So, and this is for a seat. So the spacing here, of course, isn't supportive enough for a floor, just in case you're wondering. It's a stolen image. So we have 61 inches across the top There's 24 and 7/8 inches between in depth in the window, and then we have 104 inches across the front. In order to find all the angles in this plan, I need to first find some right triangles. So we're going to just drop a vertical line straight down here. Okay. If I drop a vertical line here, that means I could easily find this angle. I'll call it angle 1. I can find angle 2. Let's label the pieces that we know. So we know for sure that 24 and 7/8 of an inch is that length. So the distance from the front to the back. We can calculate what is this distance. Now, typically a bay window is going to be symmetrical. So what's that length? Well, I would do 104 minus 61. So 104 minus 61 leaves us with 43 inches. I'm going to split that between two sides. So 43 inches divided by 2 leaves me with 21.5. So we have 21.5 inches here. Okay, so there's our triangle. I want to find angle 1 and I want to find angle 2. If it's helpful, resketch the triangle down lower. And that just takes away some of the numbers from it. So I want to find angle 1, angle 2, and this is 24 and 7/8. Now, when you look at that, that's a 4, not a 9. When you look at that, you might want to convert right away to a decimal. So 24.875. And then we know across the bottom, we have 21.5 inches. Now what we need to do is we need to label each of our lengths. And let's label, so let's find angle 1 first. Okay, let's find this angle first. So angle 1 is going to be, tells us that, okay, 21.5 is adjacent, 24.875 or 24 and 7/8, this is going to be opposite. Okay, so we have adjacent, we have opposite. Let's figure out what is angle 1. So the tangent of angle 1, call it angle 1 like this, or just, let me see. I'm just going to write it the way I wrote it in my notes the other night, because sometimes you overthink when you get writing things. So the tangent of the angle is equal to opposite over adjacent. So the tan of angle 1 is going to be equal to, I'm going to just put the little 1 with there, because if I just leave 1, I'm afraid you'll mix it up with a number. So the tan of angle 1 is going to be equal to 24.875 divided by 21.5. So the tan of angle 1 is equal to, let me see here, which plug them into my calculator. 24.875 divided by 21.5. This is where you're going to keep some extra decimals. Tan of angle 1 is equal to 1.15698. We'll say I've got 5 decimals there. Okay, then we do our shift tan. So tan, inverse tan of 1.15698. And that gives us our angle. I get the same answers as I did yesterday, 49 degrees. Okay, so angle 1, so we could also say angle 1 is equal to 49 degrees. Now, do you remember from before, all of the angles in a triangle add up to 180 degrees. So if we want to find angle 2, it's equal to 180 minus the 2 angles that we know. So 180 minus 90 minus 49. And you will find that you get 41 degrees. So we didn't even have to use extra trig for that one. The only issue is, if you look at the plan, we figured out what angle 2 is, but that's not the whole angle. That's not the entire angle that you would have in the seat. So what's the whole angle in the seat? So the large angle large angle in the seat is going to be equal to angle 2 plus 90 degrees. So you've got 90 degrees on that corner, which is equal to 49 plus 90. It's 139 degrees. Whoops, not 49, 131. Sorry, I copied down the wrong number. Erase here. It's not 49, we use 41. There we go. Plug the 1 in there. I should have used, I was reading off the side here, and there we go. 41 degrees, or the big angle, is going to be 31. So if we go back to our plan, and I'm going to erase this little bit to make it easier for us to see now, and we can label that angle. Now this angle is 131 degrees, and then here we have 49 degrees. And on the other side, it's symmetrical. They would be the same. So hopefully that's not too complicated for you. There's just a few questions to practice in your quiz. So that'll let you get a little bit of extra practice with them. You will notice we use tan more than any other ratio. And that will generally be true in real life, as tan is the most important ratio to use. So if in doubt, pick tan, but don't always assume it's tan. There will be a few where you'll be looking for a hypotenuse or have the hypotenuse, in which case you're going to need to use cosine or sine. So always double check, but oftentimes if you're in doubt, you will end up using the tan ratio when it's a practical application. All right.